This is me Vijay Kumar, Assistant Professor, Department of Electrical and Electronics Engineering. So we are seeing the video lecture series, DC Circuits Basics. I think first lecture series we discussed about currents and then voltages and then power, energy and resistors and then ideal voltage sources. So this kind of things already discussed. So today class we will discuss about resistors are connected in series and then resistors are connected in parallel. So resistors connected in series and resistors are connected in parallel. Today class we will discuss about resistors connected in series. Just assume what is meant by resistor. So this is the resistor symbol R. That means at normal condition current flow from a point A to point B, it will flow here. So without any distractions or without any resistance, it's a straight line path. Just think about the diagram. So here the resistors are in zigzag conditions. That means the electron flow move here and then it will make some kind of disturbances, and then after that the electrons are flowing here. That means this element will resist the flow of electrons or limit the flow of electrons or regulate the flow of electrons. That is called as a resistors. So what is the purpose of resistor? So resistor will help limit the electrons as well as regulate the electron. And also if what happen if the two resistors are connected in series, what will happen? So just think about that. So we have one resistor, and then again I have another resistor. So resistor A and then resistor B. So that is called as RA and then RB. The two resistors are connected in series. So what will be the resultant resistance, or otherwise it is called as a R equivalent resistance in between point A and then point B. So we have a resistors RA, for example 10 ohm. So RB it will be 20 ohm. Just imagine that. So what will be the R equivalent? So because when one electron move from this point to this point, so here 10 amps of electrons move from here. First it will meet the resistance RA. It has a 10 ohm. So automatically we have in a drop or electron drop or a voltage drop. So after that we have in a new value of, for example, 9 amps. And then again it will meet out the 20 ohm resistor, that is called as a RB. After that it will go to point B. So finally it will get a 7 amps or a 6 amps. So this kind of things. So that means what happened? So when the resistors are connected in series, okay, so when the two resistors are connected in series, R equivalent equal to RA plus RB. That means we have in a two resistance R of A plus B. So that means 10 ohm plus 20 ohm. The resultant will be 30 ohm. So that means RA, RB, 10 ohm, 20 ohm. This is equivalent to 30 ohm resistor. So this is the resistors are connected in series. So for example, this is for two resistance. Just imagine if the resistors are 10 resistance or 20 resistance. So R equivalent equal to summation of I equal to 1 to N R of I. That means R1 plus R2 plus R3 up to Rn. So this is the resistors are connected in series. Okay sir. So where we are implementing this kind of applications, resistors are connected in series. For example, in manufacturing aspects we have a different kind of resistors. For example, 2.2 ohm, 3.3 ohm, 5.6 ohm. So this kind of values are there. So I need 31.27 ohm. So what happened? I need to construct my own way of resistor. After that it will have some sort of outputs. So the resistance will help to design a circuit with desired value but in market we don't have that kind of desired value. So that's why we need this kind of resistance formula. And also when we are connecting two or three loads connected in series, automatically that value will give the resultant resistors. Okay, so thank you. We will see on next topic, resistors are connected in parallel, in next class.